Okay, a plane flies at constant ground speed of 400 miles per hour due east and encounters a 50 mile per hour wind from the northwest. Find the airspeed and compass direction that will allow the plane to maintain its ground speed and eastward direction. Well, okay, the situation here is that we actually want the plane to fly in a vector that goes straight east at 400 miles per hour. So that might look something like that. And the problem is we have a wind from the northwest of 50 miles per hour pushing against the plane. So the actual course we have to set is going to be to the northeast so that we're pushed in the direction that we want to go. So the plane, this might be exaggerated, but the plane is actually going to have to travel like so. So that would be, that vector that I just drew would be the plane's velocity vector. So that the wind coming from the northwest pushes the plane right where we want it to go, right on target. That's the W vector. So this vector where we want to be, where we want the course of the plane to be, is V plus W, where V is the velocity vector of the plane and W is the velocity vector of the wind. Well, here's the thing. We're given that V plus W, oops, let me switch colors here. We're given that V plus W is equal to 400, 0. That would be this vector right here. We're given that W, well, if W is coming from the northwest, if you put a copy of it at 0, 0, that would be where the initial point is at 0, 0, that would be W. It would have to have the form 50 cosine 315, because if you go all the way around, this is 45 degrees. If you go all the way around, that's 315 degrees, comma 50 sine 315. Or W is equal to 25 radical 2 and negative 25 radical 2. Okay, well, we know then from the triangle law that V plus W is our resultant. And I guess I'm just kind of repeating what I wrote. That's 400, 0. Or V plus, well, W is 25 radical 2. It's the vector with the first component 25 radical 2 and the second component negative 25 radical 2. And that whole thing equals 400, 0. So this guy right here is a vector equation. And if we solve it for V by just subtracting this vector W from both sides, we will have the vector that we're interested in. So if I subtract this vector W from both sides, I get that V is equal to, remember, subtract 25 radical 2 from 400 to get the first component of V, and subtract a negative 25 radical 2 from 0, which gives you 25 radical 2 to get the second component. So that's V, and now we just want the ground speed. You can do that by just finding the magnitude of v. That's equal to, okay, the square root of 400 minus 25 rad 2 squared plus 25 radical 2 squared. And that turns out to be about 366.35. I don't think it makes sense to round that closely, to try and round that accurately, because our numbers aren't that accurate. So we could just say about 366 miles per hour. That's the speed. About 366 miles per hour. Now, if you want the direction, you can set the tangent of theta equal to, okay, go back and look at v. Okay, 25 radical 2 equal to 25 radical 2 divided by 400 minus 25 rad 2. And it is going to be, this will be a positive number, so that means theta is an angle in the first quadrant. You can see that based on the picture that we drew. So that if you take the inverse tangent of both sides, you'll get that theta is approximately equal to 5.54 degrees. Or if you want to write that as a bearing, you measure bearing, well, measure bearing based first on either the north or south direction, and then how far either west or in this case east the plane is. So essentially, if you just subtract 5.54 from 90 degrees, you'll get that the plane is north 84.46 degrees east. So that's the direction of the plane. Again, I got that by looking at the picture, realizing that, oh, okay, this angle right here is the 5.54 degrees. But bearing, I'm going to measure from either the north-south line. In this case, since I'm in the first quadrant, I'm going to start with the north and measure this angle here. So my velocity vector v is north 84.46 degrees in the eastward direction.